So in this video, we're going to be solving the 1976 Math Olympiad problem from England, where we want to prove that 19 times 8 to the power of n plus 17 is a composite number if n is a natural number. But before we go on, consider subscribing and ring the bell to not miss my latest videos. So whenever we're dealing with these kinds of problems, it is always useful to consider two cases for n. One that n is an even number and one that n is an odd number. So in the first case, let's assume that n is even. Now, any even number such as n can be represented as 2k, where k is an integer. In this case, k is a positive integer. Now, let's say our number is u, therefore u equals 19 times 8 to the power of n plus 17. Now, since we assume that n is equal to 2k, u is going to be 19 times 8 to the power of 2k plus 17. And then let's go ahead and break 19 into 18 plus 1 and break 17 into 18 minus 1. So we have u equals 18 times 8 to the power of 2k plus 8 to the power of 2k plus 18 minus 1. Now let's go ahead and factor out 18 out of these two. So we're going to have u equals 18 times 8 to the power of 2k plus 1 plus 8 to the power of 2k minus 1. Now notice that 8 to the power of 2k is just the same thing as 8 squared to the power of k, which equals 64 to the power of k. So I can go ahead and say that u equals 18 times 8 to the power of 2k plus 1 plus 64 to the power of k minus 1. Now notice that 3 divides 18, therefore 3 divides 18 times 8 to the power of 2k plus 1, therefore 18 times 8 to the power of 2k plus 1 is congruent to 0 mod 3. And also notice that 64 is congruent to 63 plus 1 mod 3, therefore 64 is congruent to 1 mod 3 because 63 is divisible by 3. Now, since 64 is congruent to 1, I can go ahead and say that 64 to the power of k is also congruent to 1 mod 3 because 1 to any power is equal to 1. So using all of this, I can go ahead and say that u is congruent to 0 plus 1 minus 1 mod 3, which means that u is congruent to 0 mod 3, which means that u is divisible by 3, and that indicates that u is a composite number, and that is true when n is an even number, right? But what if n is not an even number? What if n is an odd number? So that gets us to the second case, where n is odd. Now, an odd number such as n can be represented as 2k plus 1, but that form will not help us prove that our number is a composite number. So we need to express n in a different way. I'm going to go ahead and express n as 4k plus 1 or 4k plus 3. So whenever 2k plus 1 is not useful for an odd number, we usually use 4k plus 1 and 4k plus 3. So basically, we have two cases in the second case. And now we're going to take a look at the first one, where n equals 4k plus 1, where k is a positive integer. Notice that our number u is equal to 19 times 8 to the power of n plus 17. Therefore, if I replace n with 4k plus 1, u equals 19 times 8 to the power of 4k plus 1 plus 17. Next, let's go ahead and break 19 into 13 plus 6. So we're going to have u equals 13 plus 6 times 8 to the power of 4k plus 1. And let's break 17 into 13 plus 4. So we're going to have u equals 13 times 8 to the power of 4k plus 1 plus 6 times 8 to the power of 4k plus 1 plus 13 plus 4. Now, let's go ahead and factor out 13 out of these two. So we're going to have u equals 13 times 8 to the power of 4k plus 1 plus 6 times 8 to the power of 4k plus 1 plus 4. And at this point, let's go ahead and talk about 6 times 8 to the power of 4k plus 1. So 6 times 8 to the power of 4k plus 1 can be written as 6 times 8 times 8 to the power of 4k. So 6 times 8 is 48. And 8 to the power of 4k is just the same thing as 64 to the power of 2k. So u equals 13 times 8 to the power of 4k plus 1 plus 48 times 64 to the power of 2k plus 4. Next, let's go ahead and break this 48 into 39 plus 9. So we're going to have u equals 13 times 8 to the power of 4k plus 1 plus 39 times 64 to the power of 2k plus 9 times 64 to the power of 2k, and then plus 4. Now, notice that both this and this are divisible by 13 because, 13 and 39 are multiples of 13. Therefore, I can say that 13 times 8 to the power of 4k plus 1 is congruent to 0 mod 13. And the same thing is true for 39 times 64 to the power of 2k. But this one and this one are not divisible by 13. But we can do something else. We can say that 64 is congruent to 65 minus 1 mod 13. That means that 64 is congruent to negative 1 mod 13 because, 65 is a multiple of 13. So I can say that 64 to the power of 2k is congruent to 1 mod 13. So let's go ahead and replace this and this with 0 and replace this one with positive 1. So I can say that u is congruent to 0 plus 0 plus 9 times 1 plus 4 mod 13. So that means that u is congruent to 13 mod 13, which means that u is congruent to 0 mod 13, which means that 13 divides u, which means that u is a composite number. And this is true if n is equal to 4k plus 1, right? So next, let's go ahead and talk about the last scenario where n equals 4k plus 3. Let's say that n equals 4k plus 3, where k is a positive integer. So that means that u equals 19 times 8 to the power of 4k plus 3 plus 17. And then I can go ahead and break 19 into 15 plus 4 and break 17 into 15 plus 2. So we have u equals 15 times 8 to the power of 4k plus 3 plus 4 times 8 to the power of 4k plus 3 plus 15 plus 2. Next, let's go ahead and factor out 15 out of these two and factor out 2 out of these two. So we're going to have u equals 15 times 8 to the power of 4k plus 3 plus 1 plus 2 times 8 to the power of 4k plus 3 and then plus 1. Now, let's go ahead and talk about this number, 2 times 8 to the power of 4k plus 3. So 2 times 8 to the power of 4k plus 3 is equal to 2 times 8 to the power of 3 times 8 to the power of 4k. Notice that 8 to the power of 3 is 512. Therefore, 2 times 512 is 1024. And 8 to the power of 4k is just the same thing as 64 to the power of 2k. So we have u equals 15 times 8 to the power of 4k plus 3 plus 1 plus 2 times 1024 times 64 to the power of 2k plus 1. Now, since 5 is a factor of 15, I can say that 15 times 8 to the power of 4k plus 3 plus 1 is congruent to 0 mod 5. And I can say that 1024 is congruent to 1000 plus 25 minus 1 mod 5, which means that 1024 is congruent to negative 1 mod 5. And I can say that 64 is congruent to 65 minus 1 mod 5, which means that 64 is congruent to negative 1 mod 5, which means that 64 to the power of 2k is congruent to 1 mod 5. So if we divide u by 5, the remainder of this part is going to be 0. The remainder of 1024 is going to be negative 1. And the remainder of this is going to be positive 1. Therefore, I can go ahead and say that u is congruent to 0 plus 2 times negative 1 times positive 1 plus 1, which means that u is congruent to 0 plus 2 times 0, which is 0 mod 5. So that indicates that 5 divides u, which means that in this case, u is composite. Therefore, in all of the cases, we have shown that u is a composite number. So we have shown that whether n is an even number or it is an odd number, u is going to be a composite number. So that means that u is always a composite number. Great, so this brings us to the end of this video. Thank you for watching this video. Please consider subscribing for more contents like this, and hit the like button if you enjoy watching this. Hopefully I will see you later. Goodbye for now.